Welcome to episode 1 of Math Dog, the smartest dog in the world. I'll prove it. Nikki, down, down, down. Close enough. Bed, bed. Oh, pretty good, pretty good. Sit. Oh, that was down. Very good. Shake. Shake. Now that's her brilliance. She doesn't shake. She's learned not to shake just from watching the news. Okay, Nikki, how should we greet each other? Yeah. Dance? Okay, good job, Math Dog. Math Dog and I are going to explain exponents. First, we'll talk about multiplication. Let's say that Math Dog has 3 dog bones. Look how intently she's watching today. Her focus is excellent. Let's say Math Dog multiplies that by 2. Now she has 3 times 2, 6 milk bones. Now, Nikki might prefer if she took her 3 milk bones and squared that. 3 to the power of 2. That would give her 9 milk bones. She'd be doing even better. Look at that intense concentration. She loves math. 3 times 3, 3 squared. 3 times 2. Gotta keep that in mind. What's that? Oh, the number 2 sometimes has an effect. Okay. Don't forget to take the bathroom pass. Folks, this is a note page. You don't have to copy all of it. I'm going to do some work here with explanation. Then I'm going to suggest that you copy this down for notes. You could always stop the video fun and write down as much as you'd like if you'd prefer. But here we go. We know that 3 times 2 equals 6. Math Dog just reminded us of that. 3 squared equals 3 times 3, which is 9. Okay, we have to keep in mind that this 2 here and this 2 here behave differently. This is a plain old number. This is an exponent. They have different jobs. They behave differently. For example, in this problem, the 3 times 4 equals 12. Nothing new about that. Now with the exponents, x squared means x times x. X to the third means x times x times x. How many do we have? We have 5 of them. So the answer to this one would be 12x to the 5th. What could we do in the way of notes? Well, let's take and write that one down. We'll do x squared times x to the third equals x to the 5th. When you multiply powers, you add the exponents. Ooh, tougher one. The 5 and the -2, the coefficients, are plain old numbers. You multiply them just like you always have. With negatives, gotta be careful. And then we're multiplying powers, so we add the exponents. Hey, let's talk division. Here we're dividing. The 6 and the 2 behave differently if they're coefficients, plain old numbers, than they do if they're exponents. We know that 6 divided by 2 is 3. You've known that for years. Now with the exponents, x to the 6th, let's draw out at 6 x's. And then let's draw out 2 more down below. Well, let's see here. X over x, that's equal to 1. We could cancel it off. I'm going to cancel it off with a big fancy looking 1. And then I'm going to do it with another big fancy looking 1 for those x's. What are we left with? X to the 4th. 4 of them multiplied together. So when we divide powers, yeah, keep the coefficients separate. They're just plain numbers. But the exponent rule, when you divide powers, you subtract the exponents. Well, let's put a good example of that down in our notes. That's a pretty good one to have in your notes, I'd say. All right. Well, now that we've learned how to divide powers, we would do it here. Take the top exponent, subtract the bottom one. Oh dear, negative exponent. How do negative exponents work? Well, let's see here. Let's draw it out again. X squared up top, x times x, down below 5 of them. Start canceling with a fancy 1 if you like. Or just a plain line. And what have we got? We've got 3 x's on the bottom. X to the 3rd. Can't leave the top of a fraction empty, so we'll put a 1 up there. Notice how a negative exponent just moves things. It took this from the top of a fraction. Yes, it was on top of a fraction. And it moved it to the bottom. So a negative exponent rule, well, let's make ours look something like this. Let's put a negative on the top, but let's also put a negative on the bottom. Because all a negative exponent does is move things. That's its only job. It doesn't make the answer negative, no. So let's see here. This x term is going to go down to the bottom. And we got rid of its darn negative sign. The c will come up to the top. A negative exponent moves it. That's all it does. Let's use our division rule again. And here we have the number exactly the same on the top and the bottom. So 4 minus 4 is 0. X to the 0. X to the 0, well, let's see, what's that equal to? Wouldn't you agree that anytime something is the same on the top and the bottom of a fraction, like 4 over 4 or 10 over 10 or anything over itself, is always equal to 1. So maybe our 0 exponent, x to the 0 equals 1. Careful, careful though. They're going to try to mess with you. They'll put something like a negative sign or another number out in front. This 0 is only talking to the x. It's only communicating with the x. So x to the 0, that's 1. But this darn negative sign or number or whatever might be out in front, that's just loitering around, minding its own business, and it doesn't get worked on by that 0. We'll do more of those on an assignment in a moment. Now let's see, what have we got here? We've got a power of a power. Power of a power. Let's draw it out. X squared is x times x. But we have that multiplied by itself 3 times. So we've got x squared times x squared times x squared a 3rd time. How many have we got? We've got x to the 6th. We could do it without drawing the x's if we remembered the rule. Power of a power, you multiply. Why don't we put that one down as our last bit of notes? Now, after that exciting and excellent explanation of exponents, remember the egg crate? Tee-hee. We now have notes. Want to take a moment, pause the video, copy those notes down to your page? You want any of this mess over here also? I suppose maybe. I'll give you a moment to do that. And then we'll come back with the no stress assignment. No stress assignment at all. I'll explain why there's no stress. Okay, feeling that?
Yes.
All right, folks, here is the no stress assignment. It's no stress because, first off, I'm writing no stress at the top of the page in big capital letters. Right there, that makes it less stressful, doesn't it? Also, when you're done copying this, I'm going to work it with you. I'm going to do it with you. So you could just follow along and just write what I write. You could even fast forward, pause the video, and trick me. Just write down the answers on your page, get it done. Or, with not that much more effort, you could know how to do these darn exponents. So what do you say we get started? I'm going to work it from problem 1 through problem 13. I'll try to go kind of quick, and then you can stop it, you can rewind it, you can look at whatever you want to look at, and you're going to send me a picture of your work by April 10th. That's another reason why there's not much stress here. That gives you some time to work on this, doesn't it? Name, period, date, assignment. This we'll call the YouTube assignment, shall we? Okay, here we go. First off, I'm going to begin by keeping my eye on these excellent notes that we just made. When you multiply powers, you add the exponents. Do you need a calculator? If you do, you got it handy. Okay, let's see. 5 plus 9, that's 14, plus 7, 21. This is x to the 21st power. Now here we're multiplying. Remember my point about keeping the coefficient numbers separate from the exponents? You multiply, because it's a multiplication problem, -6 times -6, positive 36. Then you multiply the powers. But how do you multiply powers? By adding the exponents. 4 plus 2. 4 plus 2 is 6. 1, where's the 1? The invisible 1 is right there. Y all by itself is y to the first. 1 plus 5, 6 again. Okay. Hey, here's a 0 exponent. Let's go down. I told you they were going to mess with you with this here, huh? There's something to the power of 0. But unlike in my notes, this one is completely wrapped up. So the whole thing is raised to the power of 0. Thus, the answer is 1. Let's just say this was different. Let's just pretend it was -9 to the 0 like that with no parentheses. That one would be equal to -1 because that negative would be out front. That can trick you. Here's another one where the whole parentheses is raised to the power of 0. When that happens, the answer is 1. Not so bad, huh? Okay. This looks like division, and thus it is. Remember the rule for dividing? Top exponent minus the bottom. X's. 12 minus 6 is 6. Y's. 10 minus 5 is 5. Oh, it's starting to look nasty now. Are you going to remember to keep the 8 and the 2 plain old numbers? Those coefficients, that's just 8 divided by 2. That's equal to 4. We were just talking about how you subtract in a division problem. Yeah, you subtract exponents. You don't subtract plain old numbers. You've known that 8 divided by 2 is 4 for quite some time. Keep doing that. Let's see here. 7 minus 4 for the x's. That's x to the third. 13 minus 4 on the y's. That's y to the ninth. 5 minus 4 on the z's. 5 minus 4 is 1. You could write the 1, but you don't need to. That invisible 1 is very happy staying invisible. A negative exponent? Ooh, what does that do? Let's see. Negative exponents. Oh, it moves it from the top to the bottom, or maybe bottom to top. This one's on the top. Yes, it is. It's up top of a fraction. So when we move it, it goes down to the bottom. Gotta leave a 1 behind up top. Can't leave that open. And if you can work out the 4 squared easily, you do. If it's something like 17 to the power of 10, yeah, leave it 17 to the power of 10. Here we've got a negative exponent on the bottom. This time it comes up to the top. 5 to the power of 4. Now, can you multiply 5 times itself 4 times? Go ahead, try it real fast. 5 times 5. Let's say you couldn't do that real quick. Let's say you were going to do that on your calculator. Most calculators you would have a button that looks like that. That's your power button. You put in the base, then you hit that exponent key right there, and then you hit the 4. 5 to the power of 4 equals 625. You could have multiplied that out in your head. That would be super. But that key is a good one to know about. All right, let's see here. Division again. 6 minus 9. 6 minus 9, I believe that's negative 3. There's your negative exponent again. We already saw what to do with that. It moves it. Did it make the answer negative? No. Sometimes folks do that. They say, oh, negative exponent, they make this a negative. Nope, its only job is to move it. Division. Let's check our division rule. If they're powers, you subtract top minus bottom. This 32 and this 4 are not powers. Those are plain old numbers. 32 divided by 4, oh, how could you cut that into 4? So, how if we cut it in half? 16. Cut it in half again, 8. All right. Then you go along happily dividing the powers. Negative 3 minus 1. Careful, these are negative signs we're talking about. Now, you know what they do. They cause mischief. Negative 3 minus 1 minus negative 4. Ooh, look at this one. That's gonna really try to get you. It's not 7 minus 1. No. It's 7 minus negative 1. How do you subtract a negative? Well, you add. That's y to the 8th. Hey, that's one to keep your eye on. That causes all sorts of mistakes. We're going to finish this problem off now. We've still got ourselves a negative exponent. Let's fix that up. We've got our 8 up top. Nobody's moving the 8. The negative exponent's not talking to the 8. It's only talking to the x. The x has got to go. Down with you, down to the denominator. Y to the 8th remains in the numerator. Done. Okay, let's see. What do we got here? Oh, we've got something raised to a power negative 5. Well, negative 5, I'm going to wrap it in parentheses. It gets raised to the power of 3. X also gets raised to the power of 3. You could think of this as a power of a power if you felt like it. You could think of it as this thing. 2 times 3 here in the notes. This would be 1 times 3. 3. Well, or you could just say it's x to the 3rd, sure. All right, negative 5 times negative 5 times negative 5. Oh dear, how are we going to do this? I like to do the negative sign first. There's 3 of them. Negative, another negative, now it's positive, another negative. Oh, it's gone back to being negative. And 5 times 5 is 25, times 5 again, 125. Maybe that's one where you grab your calculator and look for that power key, perhaps. Yeah, all right. And we can't forget about our x to the 3rd. It's funny in math, as soon as you forget about something, you get the wrong answer. All right, hey, let's keep finishing this up. Sorry I squished these on the bottom a bit, but I wanted to get them all in there. So what do we got here? We got 5 to the power of negative 2. I'm just going to write that to get it started. Some folks are going to be doing that in their head. All right. Negative times a negative. Yes, it's a power of a power. You multiply. Negative times a negative is a positive. Positive 14. And let's see here. 9 times negative 2. That's negative 18. We're going to have to fix that negative in a minute. And z, negative times a negative, that's a positive. Positive 4. Do I have room to fit this on here? Okay. Let's see here. I've got a negative exponent, so that's going to be 5 squared down below. Can we do that in our heads? 5 squared is 25, but it's down below because of the negative exponent. X to the 14, no negative exponent there. It's happily going to stay right where it is. Negative exponent, down with you. Down you go. And a positive exponent, you're okay. Z, you stay right put. Yeah, looking pretty good. And last one. This 2 here, back to our original idea. Sent Math Dog scurrying for the bathroom. The 2 and the 2 behave differently. 2 to the power of 3. Let's write it down. Still up top. 2 times 3. X to the 6th. Boy, are you seeing why these are going to work differently. This is 2 to the 3rd. This is 2 times 3. And why 2 times 3? All right. And z down below. 2 times 3. Well, that's looking pretty good. No negative exponents. The x, y, z look pretty good. 2 to the 3rd. Are you going to multiply them? You multiplied all the other 2's and 3's. Are you going to multiply 2 times 3? Of course not. 2 to the power of 3. 2 times 2 times 2 is 8. You know that, but you know what happens is folks start working on these and they get busily multiplying 2's and 3's and suddenly everything looks like a multiplication problem. No, no. So wrapping up our no stress homework assignment. This isn't your only homework. There's going to be more, but that is the work and the notes for your no stress YouTube assignment due on April 10th. Why don't you work those problems, look them over, email me if you've got questions about why something worked the way it did. See why this is a 25, see why that's an 8, any of those. And I'll try to help you out some more. Or you can rewatch the video, especially the stuff with Math Dog. Let's check with Math Dog. Did I make any mistakes, Math Dog? Or are you feeling okay about it? Math Dog looks pretty content with the explanation. Until next time, we'll say goodbye. Thanks, everybody.